I'm Shiki and I'm going to talk about Simpson's rule.
I'm going to be talking about what is Simpson's rule, its applications and constraints. I'm going to be comparing it with trapezoidal rule and be discussing about the advantages and disadvantages of using Simpson's rule. Simpson's rule is a method to find the sum of areas under parabolas as an approximation for the value of the area under a curve y equals to fx. It is also used for approximating a definite integral like fx dx through the value b to a. The constraints of using Simpson's rule is that the area under the graph must be divided into even strips so that Simpson's rule can be applied. The way that Simpson's rule is applied is that the area under the curve is divided into even strips which are labeled y0 to y6. The first of the fx value is a and the last is labeled b. A is the lower limit and b is the upper limit of the fx value. Parabolas are also used to approximate each part of the curve. By looking at the graph previously shown, we can use the equation shown below to approximate the definite integral. Fx dx through the value of b to a is approximately equals to h over 3 times bracket y0 plus yn plus 4 times the total of odd ordinates y1 plus y3 plus yn minus 1 plus 2 times the total of even ordinates y2 plus y4 plus yn minus 2, where y0 is the first strip and yn is the last strip. The ordinates of y are multiplied by the odd ordinates of y are multiplied by 4 and the even ordinates of y are multiplied by 2. By comparing Simpson's rule with trapezoidal rule, we find that for Simpson's rule, we need to divide the area under the curve into even number of strips, and it uses some areas under parabolas to approximate the value of the area under the curve. The formula for Simpson's rule is h over 3 times y0 plus yn plus 4 times the total of odd ordinates plus 2 times the total of even ordinates. While for trapezoidal rule, there are no constraints on the number of strips, and uses the sum of areas under strips as an approximation for the actual value of the area we have. The formula for trapezoidal rule is shorter, which is h over 2 bracket y0 plus yn plus 2 plus y1 plus y2 plus yn minus 1. The disadvantages and advantages of Simpson's rule is that for advantages, it is easy to use. For disadvantages, it can only be used when there are even number of strips under the graph with odd number of data points. It is also more tedious to use than trapezoidal. This is question 2b from tutorial 4, and the question is to find the approximation of the definite integral of square root of sine theta d theta through the values pi over 2 to 0 with and given n is equals to 6. First of all, we let y equals to square root sine theta. Then we find h, which is b minus a over n, which is equals to pi over 2, which is the upper limit, and 0 minus 0, which is the lower limit, over 6, which is n, which is also the number of strips. And we find that it equals to pi over 12. Then we plot a table consisting of theta and y, which is also square root sine theta. We put 0 as the first value of theta which is also the lower limit of the integral. Then we increase each of the value by pi over 12 as shown here until we get pi over 2, which is the upper limit. For y, which is square root of sine theta, we substitute the value of theta inside the equation to find the values here. After finding the values of y, we label the first value as y0, second value is y1, and third value is y2, and so on until y6, which is the last value. After that, by using Simpson's rule, we substitute the h and y value into the equation h over 3 plus y0 plus yn plus 4 times the total number of odd ordinates plus 2 times the total number of even ordinates, and thus we already find h is equal to pi over 12 and the different values of y here, so we just substitute inside. If you have counted properly, the answer should be 1.19. This is the example 2 from maths textbook, which is to find the approximate value of definite integral y over y plus sine x dx through pi to 0 given n is equal to 6. First of all, we let y equal to 1 over 1 plus sine x, and then we find h, which is b minus a over n, where b is the upper limit and a is the lower limit of the integral. We find that h is equal to pi over 6. Then we plot a table as previously shown. We plot a table of y and x, and we put the first value of x as 0 and subsequently increment it with pi over 6 until we get pi, which is the upper limit. Then we substitute the value of x into the equation y equals to 1 over 1 plus sine x and find the values shown here. After that, we label the first value of y as y0, second value as y1, third value as y2, and so on until y6. After that, we substitute the values of h and y subsequently into the equation, and we find that the answer is equal to 2.